Hello everyone, welcome to another episode of Easy Chemistry just for you. In today's class, we will be discussing about scientific notation. What is the importance of scientific notation? Why should we learn scientific notation in chemistry and all those things? We know chemistry is a branch of science that deals with the study of atoms and molecules, right? So, these atoms and molecules have extremely very low masses and are present in extremely large numbers. So a chemist have to deal with very big numbers, like you can see 6022. Again there are 23 zeros. That's a big number for the molecules of 2 gram of hydrogen gas, or as small as 0.0000. It goes on up to 166 gram mass of a hydrogen atom. So a chemist have to deal with extremely very big numbers as well as very low numbers. And it's really a challenge, right, to do simple mathematical operations like addition, subtraction, multiplication, division with such a big numbers, right? With such numbers, it's really a pain, right? And this problem is solved by using scientific notation for such numbers. We can say this big number can be written like this using scientific notation. So let's see what is scientific notation and how do we express very large numbers in scientific notations. Okay. So why do we learn scientific notation? Because we know, as we are learning chemistry, we know chemists have to deal with very large numbers. And doing mathematical operation with such large numbers is quite difficult. It's really a pain for them. Even counting those zeros itself is really a pain, right? So we have to find a way to write these numbers. And scientific notation is like an abbreviation. It's like a shorthand method or a shorthand way to write numbers which are really very big and really very small. It's like an abbreviation. So it's a shorthand way to express numbers which are really big and really small. See, you can see here a very, very big number, right? This number itself have 23 zeros. 306 after 6 there are 23 zeros. Counting the zeros itself is really a pain, right? And we have to express in its short form, or we have to make an abbreviation of this number using scientific notation. That's how scientific notation helps us. Let's see how to do it. Let's see. For writing a very large number or a very small number in scientific notation, first what we have to do is we have to find the decimal. Is there a decimal in this big number or at the small number? Now let's see this very big number. Can you see a decimal in this number? You cannot see a decimal. If there is no decimal, means there is a decimal at the rightmost end, right? So there will be a decimal here. Now what we have to do is we have to shift this decimal to the left side so that there will be only one digit to the left of the decimal point. We will be shifting the decimal from the rightmost end to the left until there will be only one single digit at the left side of the decimal point. See? Now you can say this 3 point. It will be like 3 point. We are shifting the decimal from the rightmost end and we are moving it to the left until there will be only one single digit at the left side of the decimal point. And next what we have to do is we have to count. We have to count how many places we have shifted the decimal to the left. Now see, it's like 3, 6, 9, 12, 15, 18, 21, 22, 23, 24, 25. We have shifted the decimal 25 places to the left, right? So we have to write this 25 here. And now what we are doing is we are discarding all the zeros, all the non-significant zeros. We are discarding all the non-significant zeros. All the zeros are non-significant zeros. You might have studied about significant numbers, and in coming classes we will be studying it in detail. So all these zeros, the trailing zeros, are non-significant. We have to discard it. This zero is a significant number because it comes in between two non-zero digits. Okay. And we have to rewrite this big number as 3.06 into 10 to the power of 25. From where this 25 came? This 25 is the number of places we have shifted the decimal point. We have shifted 25 places, the decimal to 25 places to the left, so that there is only one single digit at the left side of the decimal point. And how many places we have shifted the decimals, that we have to write here. That is the 10 to the power of 25. Now you can see this big number we have just abbreviated, or we have just compressed this huge number into this 3.06 into 10 raised to 25. This is how we will represent this big number using scientific notation. Now let's see the next number. This is a very small number. This 0.00000 goes on and 00369. That's the number. And now we have to compress this number and express it in scientific notation. So we know the first rule. We have to see the decimal point, right? So where is the decimal point? Yeah. Here in this number, the decimal point is on the left hand side. In previous number, it was on the right hand side. And we shifted the decimal from right to left, so that there is only one non-zero digit at the left hand side of the decimal point, right? And in this case, we have to shift the decimal from left hand side to right hand side, so that there is only one digit to the left of, one non-zero digit to the left of the decimal point. So the decimal will come here. We have to shift the decimal from the left hand side to up to the right, so that there is one non-zero digit number to the left of the decimal point. So the decimal will come exactly here, right, between 3 and 6. Now we have to rewrite it, 3.69. And what we have to do is, what is the next step? We have to count how many places we have shifted the decimal. We have shifted the decimal to 24 places, 6, 9, 12, 15, 18, 19, 20, 21, 22, 23, and 24. We have shifted the decimal from left hand side to right hand side for 24 places. See, 24. And we have to rewrite it in the form of 10 to the power of 24. But you can see a minus 24 here. Why it is minus? Yeah, because it is extremely very small number. And so for a small number, we have to shift the decimal from left hand side to right hand side. For a small number, the power will be negative value, having negative value. So we can express this very small number into 3.69 into 10 raised to minus 24. See, if you are asked to add these two numbers, it was really a tough job, right? Now it's easy for us to do any numerical calculations for these two numbers, right? Now you can see that, in a scientific notations, the numbers are expressed in the form n into n, 10 raised to n, right? It's an exponential notation in which any number can be represented in the form n into 10 raised to n, where n is called the digit term, the capital N is called the digit term, which varies from 1.00 and 9.99. That means 10. So this digit term can be varied from 1 to 10. And the small n, that is the exponential term, and it is having either positive or negative values. Yeah, we have seen this, right? N into 10 raised to n. N into 10 raised to minus n. So this is the capital N, the digit term, and this 10 to the power, that is the small n, the exponential term, right? And it may have the values positive or negative. So it's an exponential notation in which scientific notation is an exponential notation in which any number can be expressed in the form n into 10 raised to n. Okay. Now next, one example for you. Can we write this number using scientific notation? 232.508. There are not much zeros in this number, right? So counting is very easy. So what is the first thing we have to do? Yes, spot the decimal. Yeah, we spotted it. It's exactly in the middle. Now what? Shift the decimal to the, it's a positive number, big number, right? So to the left side, so that there is only one single digit to the left side of the decimal point. So we have rewritten this. There is no number to discard, and we have to count how many places we have shifted the decimal. How many places we shifted the decimal? Just 2 places, right? We have just moved the decimal just 2 places to the left. So into 10 raised to 2. There are no non-significant zeros to discard. So 2.32508 into 10 to the power of 2. This is how we can write this number 232.508 in scientific notation, right? While writing this, the decimal had to move to the left by 2 places, and same is the exponent 2 of 10 to the power of 10 in scientific notation. So this is now written in the form n into 10 raised to n, where n can vary from 1 to 1.00 to 9.99, right? And small n is having positive value. Now let's see this number, 0.0016. How can we write? Spot the decimal first. Yeah, we spotted it. Now what? It's a small number, so we have to shift the decimal from left to right until there is a non-zero digit to the left. So it will move from 1 place, 2 place, 3 place, 4 place, right? So that we can rewrite as 1.6, discarding all the non-significant zeros, into 10 to the power of, how many places we have shifted? 4 places. So minus 4. It is a small number. And we have shifted the decimal from left to right. So we will express it in 1.6 into 10 to the power of minus 4. So the decimal has to be moved 4 places to the right, and minus 4 is the exponent in the scientific notation. So this is all about scientific notation. So we have learned about scientific notation. Why do we learn scientific notation now? Yeah, we should learn scientific notation because chemistry is a branch of science that deals with atoms and molecules which have extremely low masses and are present in extremely large numbers. So for a chemist, it's very hard for them to deal with such a very big and very small numbers. We have seen this number in the beginning. This is the number for the molecules of 2 grams of hydrogen gas. If we are rewriting this number using scientific notation, see, moving the decimal from right to the left until there is one non-zero digit to the left side, and discarding all the zeros and counting the places which decimal has been moved, we can rewrite this number as 6.022 into 10 raised to 23, which you are very much familiar, and that is known as the Avogadro's number. Hope this video helps you a lot, and next class we'll be discussing about the mathematical operations using scientific notations. See you next class. Bye.